Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Today, I'm going to start testing the Aiyima A07 Max with this QuantAsylum. I have the new QA403 right here. I had the QA401. I still have it actually. I'm going to have to, get rid of that, I guess. I bought that one. The 403 they gave me. 2 thumbs up to QuantAsylum. Thank you. So I'm going to start my first test with it. And what I'm going to have to do first is we're going to find kind of like a low power, the 1 watt range, and then the high power range. And I want to find a high power that it'll actually do continuously for a while. And then something in between. So that way, when we do all these automated tests with the QuantAsylum, we set up kind of the high and low, and it takes these steps in between, takes a whole bunch of graphs. So I guess I don't really need to find a middle value because it'll just take a bunch of steps between the high and low. So let's go ahead and do that and get going with this, okay? I'm going to bring my laptop in here and we're going to start this test. I'm going to use the picoscope back here so that I can show you on the screen what it looks like, what the waveforms look like as we find the max and the min, okay? All right, so hey, let's do it. Oh, and I got my little temperature meter here. Usually keep it up here somewhere. But I'm going to check the temperature of this thing. It's nice and warm right now. It's been running for a while, but we're going to heat this bad boy up. So let's do it. Okay, guys, so we have the Aiyima A07, and it's nice and warm and toasty. I've let it warm up. I've been doing some testing and setting things up. So we're doing a differential input, essentially. We've got the plus and minus here going to the input, and I've got both the left and right channels kind of tied together. I could do separately, but it's just a lot of cables. And right now I'm really just looking at the left side, but I'm powering the right side too, just to get the signals on both sides of the board, see if that affects anything. So we got our little LEDs here. This is a new QA403. Love this thing. Thank you, QuantAsylum. I bought my first one. They gave me this one. So, all right, so then down here, I've got the Omicron, which I used last time. So we're going to use this, okay, testing this guy. And I have 2 differential probes. One, this one, looking at the input voltage, okay. So I got in times 10, so not a big signal. So, and then I'm using this differential probe over here. It's the mix, they're both mixed sigs. But I'm using this one. And instead of going to my mixed sig scope, I'm using my picoscope, which is right here. Okay, so you can see the probes coming in here. The output is tied to this one, so it's 50x. Okay, so that's going to channel B, the red one, and A is the input signal. Okay, so got that sitting up here on a QuantAsylum box, I think. And then I'm I'm bringing signals into the computer here and got all kinds of stuff going on back here, guys. Got my little hard drive here, and so I've got the computer right here. Okay, so I'm going to be showing you these signals, and what we're going to be doing essentially, I'll just tell you real quick, is channel 1 we're going to set up for the input, channel 2 we're going to look at the output. So when I'm looking at the input and output, I'm just looking to make sure I know what the input signal actually is. And then I'm looking at the output to make sure we're not clipping and to see what voltage we actually have. And that's going into this resistor here. Maybe I'll hook up, I think I'm going to hook up channel B too, so it's powering both channels so we can get power going through the amp through both channels. But okay, all right, I think I'll do that as well. But anyway, so that's what we're going to do. I'm using my differential probes and the picoscope to verify measurements, and then I'll be using the QuantAsylum QA403 software to look at the signals and do the testing. All right. And just kind of a funny note, I've got my EcoFlow here charging my PC, it's my Mac, just because on this end of the bench, I didn't have a cord coming over here. And this guy was just sitting handy, so I just plugged that in. So, yeah, there you go. Love that little EcoFlow. All right, so I have the 2 load resistors. We're starting off with the 8 ohms for today's test. So they're sitting on the silicon mat. so they won't melt anything, don't have any wires next to them or sitting on them or anything like that. So there we go. And here's all my differential probes and all my connections, kind of crazy stuff. All right, guys, so this is the initial setup. I've got essentially 1.414 volt peak line right across here. Okay, and so we got our scale over here is 2 volts up, 2 volts down, minus 2 volts here. Okay, 0 center here, our triggers right here. So this is our setup. Frequency down here, you see 1 kilohertz. Now what happens is this guy, you know what I can do to make this a little more obvious? Let's get some more time scales in here. Okay, so you can see the way the instrument, the QuantAsylum does this test. It'll put out a frequency and then it'll pause for a moment. Okay, I think the scope is scanning it and then it scales it to the screen size, so that's why it kind of goes over sometimes. But if you watch it go across, so let's get some more time in here so it'll be more obvious to you. So there you go. So it runs for a little while, turns off for a little while. Okay, so if I bring my cursors out here, we can kind of see what the off time is. I'm not going to be super precise, but right about there. Grab the other one, put it right about there. So it's off for, what is this? About 357, 358 milliseconds. Okay, and then I'll grab this one, and then it's on for, what is that? About 2.7 seconds. Okay, so it's on, off, on, off, on, off. That's just the way it does its test. So it needs to take measurements during the on time, and then it turns off, then it can, repeats the test. So, okay, so that's kind of what's happening here. Now, here we'll go back to where we can actually see the waveforms. There we go. So you can see as far as the amplitude, this is our 1 volt input, 1 volt RMS, which is about 1.414 volts peak. So that's what is going on there. Okay, got my crosshairs here, but basically I got this line right here to show you that. Okay, now let's look at the output. It's on off. Let's turn on auto. Okay, so in auto, even though we're going to about, over here on the right side, you can see the scale. It's plus minus 10. That's where it auto scaled to. And we have 4 volts right here. So we could have done 5, but it chose 10. So just to show you how that works, over here there's all these different settings. And I think if we go to 5, for some reason, I think it's because, you know how it scans and it goes over the voltage and then it takes a measurement and it scales it correctly. I think that's probably why it's doing that. It's kind of an interesting thing that happens. But so there we go. So there's our input, the reds are output. Now you're saying, oh, they're out of phase. Yeah, I put them out of phase just so if ever the waveforms are right on top of each other, it'll be, it'll be obvious that we're seeing both channels. So here they're 180 degrees apart, so it'll be obvious that you can see the 2 different waveforms, but really, they're in phase, okay? So that's our first setup for the 1 watt. All right, so let's go take a look at a couple more of these setups. All right, guys, this is a QuantAsylum QA403. So the 40 series software. Let me go ahead and start running this. Okay, it showed a spike up here from when I was previously running. And right here, I'm at full scale. Okay, so the input, we're going to go full scale, which I think gives us right here, plus minus 56 volts. The displays the output of the generator. Okay, it's the output of the QA403. Okay, so we're looking at frequency across the bottom, and yeah, so dB volts on the axis, and we're doing a log, so that's all looking good. Acquisition, we're doing FFT, and let me see what acquisition we're taking. Okay, see up here, 512K. So that's plenty. I think I could drop it down a little bit because I've been running this and I haven't really seen, I can go all the way down to 3216. I haven't seen a big change hardly any change at all. So I think our resolution is looking good. And then we can average. We're not averaging. We're not weighting. We're looking at the Hamming window for the filtering of the FFT. And we can take all these measurements. I'll show you those in a moment. Whoops. And I scan up. It's kind of funny when I grab my mouse to scan up or down, just kind of jumps real fast. So generator 1 is turned on. If I hold this down, anything you see with a line on it, you can hold your cursor down. Well, at least I do on my Mac. Maybe you hit the right button on a PC. But then it comes up 1 kilohertz, minus 5.75 dB volts. That comes out to, so I'm going to have to explain this. What we want is 1 volt RMS output, okay? But we're actually asking for 0.5 volts because using that differential output, I get double the voltage. And I don't see how to set that up in the menu. I'm going to ask our friends at QuantAsylum on if I can do that so that it'll take care of that for me. But anyway, for now, I just want to get this video out. So we're going to go ahead and set this up. So this might be something I just don't know how to do. So we're setting up a 0.5 volt input, which is really 1 volt. So our gain is going to look like it's twice as much as what it really is. Okay, so that's that. And then here's our cursor stuff. We're not going to worry about that right now. So let's just come up here, and we're sampling rate 96. I mean, gosh, we can do all kinds of other stuff here. It was at 48 by default. I put it 96 just to get a little bit more, but I haven't really seen anything yet, any changes with that. So let's go ahead and run this. Whoops, it was running. And you know, it just keeps the signal on there. It doesn't erase it. And maybe if I left it long enough for it to sample, it would. So that's what that dB looks like, that input, right? So normally it'd go up to 0 dB with 1 volt, but we're minus 5 point something dBs down, okay? All right, so now let's look at what the QA403 is bringing in. And that's the output of the Aiyima. All right, there we go. So see, we've got some gain. We're up close to 10 dB here. Now we can go over these measurements here, and let's go turn on the gain first of all. Now, I'm going to turn off this FFT because we know what it is. So there's gain of 15. It's really not that much. It's half that, okay? And it's not half that in dBs, but it's half the gain then multiplied. So I'll show you that in a moment, but I'll probably just throw it up here on the window for you. So here's our RMS measurements, okay? So this is measuring the signal on the output. That many dBs. Okay, let's see. Let's get the THC, which I know you're interested in. Okay, right now it's reading 0.075, which is plenty good. THC plus noise. It's barely up a little bit higher. Now we have a small signal going in, so whatever noise we have on the ground floor is going to be, you know, adding to that. It's more meaningful than if we had a bigger signal, right? Okay, now let's signal to noise ratio. There you go. 64 dBs roughly, okay? So if we're, say, sitting close to 10, then we would be 54 dBs down here is what we're looking for. So here's 54, and there it is right there. So that's our signal noise ratio between these two spikes. Now what we want to look for when we increase the amplitude, we want to make sure these guys, we want to watch these. When these guys start raising faster than our signal, that's when we know we're either flat topping or we're just getting distortion because of whatever reason that the amp's been driven too hard. But that's when, you know, the signal and noise ratio starts to fade away, and that's not a good thing. So, and all the distortions start going up. So we'll watch for that. So right now, this is our 1 watt test. All right. Now let me just familiarize you with this screen a little bit. Down here at the bottom, you'll see these things. It says it's connected, it's ready, acquisitions, that. There's rest, there's firmware 58, USB voltage is 3.98 something volts, current's 0.819 amps, ISO current 25C, calibration. So it's really nice that all this stuff is, you get all that information if you're interested. And then up here's our options. Okay. I just want to point out that all the noise right now, minus 60, we have 2 spikes above minus 60, and everything else is way down here. Remember, every 20 dBs, you're going 10 times the level, right? So if 0 is 1 volt, this is 100 millivolts, this is 10 millivolts, and then 1 millivolt. So we're down here at 1 millivolt kind of range. So practically nothing. All right, guys, so now that we kind of see what 1 volt looks like, we know what it looks like here, let's go find our maximum voltage, because a lot of these automatic tests we're going to do, these automated tests, they're going to ask us, I'll just show you the first one. It's going to say start here, stop there. So we're going to go across the power range, whatever power we can go from. Say we're going to start at 1 watt and go up to our maximum wattage. And we're going to see how many steps we want to take. And then we're going to say what frequency band and all this kind of stuff, okay? And this is how many steps in that frequency band, like every 500 hertz, every 100 hertz, that kind of thing. Points per octave, that's how many, readings we're going to take, the resolution. So, yeah, so it's going to ask us for this information. So let's go find what that is. So what we need to do is come back to this window. I need to turn on the generator and start creeping it up and watch when this output signal, the red signal, starts to have distortion and flatline. And I'll probably go back and forth so I can look at the FFT and see what's going on, okay? Okay, guys, so we're at the QuantAsylum window. I'm putting out the voltage, which should give us into the amplifier the full range output. So let's go look at that and see when it clips. All right, so here, let's run this. Okay, it's running. Okay, there's the input. The input's on the left, the blue, 1.414 peak, right? 1 volt RMS. And so the red one is the output. And right now it's at 1 watt. So let's crank it up until we see it start to clip or distortion gets bad. Oh, okay, they're definitely clipping. And that's at 40 volt peak. Okay, so right there looks a little bit better. Okay, let's go, now that we're close, let's go look at the spectrum. Okay, we're looking at the output, which is the signal going into the amplifier. Let's look at the signal coming in. Okay, here, look at all the spikes. Okay, now we come up here to 69 dB. That's signal to noise. That's his peak to these guys, right? So we don't want these guys to grow faster than this. And right now, our voltage on the output is 28.83. So let me see if I can crank it up. Well, first I'll bring it down, okay? And let's just watch those peaks. See, everything's dropping together. Okay, that's good. Now let's bring them back up together. And I'm watching that signal noise. It's dropping down a little bit, 68. Let's see if I drop the signal down. Okay, we're still at 68. Okay, so let's take it up. Uh-oh, we definitely dropped. We're at 51. So we're clipping there. We're at 30 dB volts. Now this is really sensitive, the knob, the amplitude. Okay, we're 68 again. I'm trying to inch it in. Okay, right about there, we start dropping our signal and noise. So let's go down just a touch. I can say it's really sensitive here. Okay, 68. And we have 28 dB volts, right? 2879. Okay, I'm going to write that down. And that gives us signal to noise at 69.6. THD with noise and without noise is about the same. 285. I'm going to write 28 for THD and with noise 29. I'm going to write 285 for THD and 288 for THD plus noise. All right, guys. So now remember, both channels are running right now. Okay. So one of the tests, I'm going to run it here at this max level for a while to see if it can run for a long time. Okay. Feel the amp heating up. Now see this 64K FFT? I lowered it just so it'd react quicker so I could watch this stuff. Now I'm going to increase it and see if it helps our signal pattern, if it looks better. I think it looks pretty darn good. I'm going to creep it up just to show you. We'll go 256. It just takes longer for it to take more math, more samples and all that stuff. But I don't really see anything improving, like as far as clarity of what all these harmonics and all the noise looks like. So at 1 kilohertz, right? So the first big spike's at 3K, then 5, so it's odd harmonics. The second harmonic's this guy down here. The fourth is this one, the 6. So the even harmonics are much lower. Closer to, this is 50, about 55 dB or less, almost minus 60. Where the odd starts at about 25. Okay. Now our signal noise is 69, so that means we're about 20 up here and we're about 25 down here. So the signal noise from peak to peak on this guy is about, well, it's almost 30, and this is like 25, so 55. And then we have all these. So, and actually this window right here shows the third harmonic at minus 54. And that's at 300 hertz. Okay, I'll get rid of those two windows so we can stretch out our waveforms a little bit. Yeah, the amplifier's pretty hot. I can rest my hand on it, but it's pretty hot. Whoa, it's getting hot. I have a feeling it's not going to run for a long time here. Here, I'll come back and I'll let you know how long it ran. Okay, guys, so right around the 100-watt area, I could go a little bit, right around 100 watts, a little bit above 100 watts, and it didn't shut off. It ran continuously, but I think the best distortion values in that was just under 100 watts. So, yeah, and it didn't seem to be limited by the 40 volts. Now, by the way, just to let you know, I'm looking at it right here. It's 48 volts, 5 amps. So I have the 48 volt, 5 amp power supply, the bigger one, okay? So the voltage was not a limitation at 8 watt loads, and I did have 8 watt loads on both outputs, so it was putting out 2 channels, and it ran hot. As a matter of fact, I couldn't keep my hand on it too long because it was pretty hot. This thing said it was in the 50s, but I felt like it was in the high 50s. So yeah, it was warm. Now, usually 60 degrees C is when you can only touch it for just a second or two, right? And so I could keep my, so maybe it was in the mid 50s. Anyway, so what do you think? So we got the settings. Now we're ready to do a bunch of automated testing. I started some of them, but the video is going to be too long. So you'll see those in the next video, and I got some more testing to do. So, all right, guys, let me know what you think. 2 big thumbs up, my patrons and members of the channel. Really appreciate all you guys. And 2 big thumbs up to Danny for being a team member. That's awesome. You become a member by hitting the button down below. You can buy me a cup of coffee by hitting the button down below. That's a new button that YouTube added a little while back. And yeah, I really appreciate it, guys. Thanks for supporting the channel and watching the video. That's a free way to support it, as well as hitting the thumbs up button. That helps a lot. And subscribing for sure. All right, so the Max A07 or A07 Max, we're underway. We're going to knock out some testing, and we're going to see, and I'm going to talk about the test results and that in another video, but let's just knock out the test first, and then I'll sit there and I'll kind of discuss what I think about it, okay? All right. Hey, oh, and yeah, it's funny. I saw that red light on the little panel that said USB power, and I'm finally thought to myself, well, why is that the only one that's red? And when I put it on the scope, it went away, and I got some better measurements. And I didn't really think about that until the measurements didn't come in as good as I thought they would. So the second time I did it with the new USB readings, it came in a lot better. So that's interesting, huh? Okay, so I'll make sure I pay attention to that in the future. And all right, we're ready to go. All right, thanks for watching. We'll see you next time.